Moving on to section 2.4, we'll now be discussing complex numbers or imaginary numbers, you might have heard these called as well. And there's really two goals. The first one is just sort of what we can do with complex numbers. So we'll be adding, subtracting, multiplying. But then we're going to relate this back to what we've been talking about in chapter 2, which is finding roots of polynomials. So to begin with, I want to first talk about what these things are, complex numbers. And to start with, what I really want to do is say, now we've had equations that we've been solving. For example, x squared equals 4. We said, well, x equals plus or minus 2 is the answer, right? So there's sort of this middle part, we get the square root of 4, and then that gives us that 2. Well, we had issues where if we said something like x squared plus 4 equals 0, when we solve this, we actually end up with negative 4. And then when we take the square root of both sides, we still have that plus or minus, but we don't really have any numbers that work in the real number system to give us negative 4. Now, mathematicians decided at one point that this wasn't really necessary. They didn't think they needed square roots of negatives. But since then, some fields of math, and actually physics as well, have required that the square root of a negative number be defined. So they created a new number system called the complex numbers. And they also decided that the square root of negative 1 now has a name. The square root of negative 1 is going to be called I. Now, I is not a variable, even though it kind of looks like it might be x or y or something like that. I is clearly defined to be the square root of negative 1. And you might also hear the phrase imaginary numbers. And so we will talk a little bit more about this. But I want to point out that imaginary is a little bit of a misnomer, because we started off with real numbers, and so then mathematicians said, well, let's call these other ones imaginary. They're not imaginary. I mean, they're not imaginary in as much as any number is really imaginary or made up, because I just wrote it down. There it is. There is I. It's not imaginary. It exists. It's there. And it forms this bigger number system called the complex numbers. So in general, we write a complex number sorry, I got some typos here. Complex number as a plus b times I. So this is the general form, and usually we use the letter z to represent complex numbers. X and y are usually real numbers, and so z often gets used to represent this complex number. Now, in this number, I want to point out that a and b are both real numbers. The first part of this, a, is called the real part of a number, and the bi is called the imaginary part. So for example, 2 plus 3i would be a complex number in standard form, and we would say 2 is the real portion and 3i is the imaginary portion. Another example of a complex number is the number 5. Notice that 5 could be rewritten as 5 plus 0i. So actually every real number, this is kind of a good result to write down, every real number is also a complex number. It's just that the imaginary part would be equal to 0. And then another thing to note is if I wrote something like -1 plus the square root of -4, this is not a complex number in standard form. We would have to rewrite this as -1 plus 2i. And we'll get more into square roots in a little bit here, but just know that if you take the square root of a negative, you just get that I to show up. But again, we'll talk more about that later on. Okay. Now, while we're discussing imaginary numbers, a common topic that comes up, just to help illustrate the point a little bit more, is we talk about powers of I. And so here's what we mean in this case. Let's start off with just, well, the square root of -1 is I to the power of 1. So that's what we're going to start with. Now let's think about what I squared would be. So if I took I squared, that means I'm squaring -1. So that means I would actually have -1. So I squared is -1, which is really useful because I is imaginary. So right here we have an imaginary number. But notice if you square it, you actually end up with a real number. So this is a fact that will come up quite a bit. I squared equals a real number and it equals -1. Now let's continue with our powers. If I said I cubed, well, this is just I squared times I. And remember, we said over here that I squared was -1, so this is -1 times I. And so actually we could rewrite I cubed as -I. So this is another fact we're going to use. If you raise I to the power of 3, you just get I again, except it has a negative in front of it. And then finally, if we go to I to the 4th, this is, over here I'll write I to the 4th. Well, this equals I squared times I squared, which would be -1 times -1. So I to the 4th actually just gives me a positive 1. And then this actually repeats itself. So let's go ahead and let me make a better table now. So if I do I to the power of 1, I get I. If I do I squared, I get -1. If I do I cubed, I get -I. And then I to the 4th is just 1. And now this will repeat, because if I do I to the power of 5, this is the same as I to the 4th times I. Well, I to the 4th is 1. So this actually equals I to the power of 5. And then you can prove this process by continuing my work off to the side there. And this actually just keeps continuing, right? So we could say this is the same as I to the 9th, I to the 13th, etc., etc. So if you have any I to the power of, let's just call this, whoops, sorry about that, I to the power of some number m, you're going to rewrite it as I to some power of 4 times, we'll just call this another number n, plus either 1, 2, 3, or it could be just 0, right? It could be divisible by 4. And then you can relate this back to either I to the 1st power, I to the 2nd power, I to the 3rd power, or I to the 4th power. So these are all going in the exponents here. But the point is you really should never have a power of I besides I to the power of 1. Everything else can be reduced to another number. Let's take a look at an example. Let's just say I had simplify I to the power of 23. So here's what I'm going to do. I'm going to take 23 and I'm going to divide it by 4. So if you divide 23 by 4, you should end up with 5 and a remainder of 3. I feel like since we just did long division, I might as well do this again. Right, so the remainder is 3. So this means that I could rewrite I to the 23 as I to the power of 4 times 5 plus 3, because 4 times 5 plus 3 is 23. this part of it is just 1. I to the power of anything, any power of 4 or any multiple of 4 is just going to be 1. So really I'm left with I cubed, and if we check our table real quick, well, I cubed is the same as negative I, so this actually would just be negative I. So essentially the way this works is if you have some I to the power of, which I was just talking about above, you take m, divide it by 4, and you get something with a remainder equaling some other number. And so then whatever I to that remainder is, this will give you your final answer. But the idea here is you're going to first divide by 4. You'll get some number. We don't care about any of that because the I powers cycle in multiples of 4, so we don't really care about this. What we care about is the remainder. And we'll go ahead and conclude our initial video there just as the introduction to powers of I.